So we're doing probability. It is geometric, so I use y. Probability that y what? Symbol number equals 5. So I'm plugging that in as a PDF, but I've already written it's a geometric. This is my probability of success. This is what I'm plugging in, so that I can go straight to the answer. Now I didn't grab. And you get, what is your answer? Point what? 0.0154. This one says 2 of them are success, so we know that's what? Binomial. It asked me again for a probability. So if you are having issues with these, I want you to think the way that I'm starting to write stuff on the board. And now I'm going to go a little bit quicker here. So B is binomial. You're doing it for P parentheses X what? Equals 2, and you should get 0.2304. Yeah.
Do you have to show your work with the equation when you have binomials of this?
So what I require on a test is, like, if B were its own separate problem and I didn't have anything else here, then what I would want to see is I've decided it's binomial. My N is what? 5. The probability of success is, and I want the probability that X, I'm probably going to switch to the board, equals 2. And if I see all of that in the answer, that's all the work I have to see. Now, the equation itself, like the 5 choose 2, that part, you don't have to ever write that out unless I ask you to write that out. So basically, you don't have to do it unless you're answering a multiple choice question where those are the answers. Part C, is that binomial or geometric? Part C says, it says average, so we're not finding probability here, but it's required to get a white one. So it's geometric, so we're getting the first success. So what's our geometric mean equation? 1 over P, so I'd want to see geometric 1 over P, 1 over 0.6, which gives me 1.67, however you round it. And what would our units be there? Joules, or whatever you want to call it. For D, and if I need to keep writing more stuff on the board, I can. I think y'all are fine with me like talking through it though. For D, it says average, not probability. The average number of successes, so that's what? Binomial, so we're doing binomial mean. So binomial mean equation is what? N times P. Our N is 10, P is 0.6. So we get 6. And then our units would be white ones, right? Yeah, I just feel weird writing that word. So it really should be balls there, but we'll just not write it for right now because that's weird. E was probably it takes more than 5. So probability takes more than 5. We're getting this. So it's what? P parentheses Y what? I don't want to write it like this. I want to rewrite it in a way I can use my calculator. So I rewrite it as 1 minus probability of less than or equal to 4. Oops. And then, so you're plugging that one in your I don't think I have the right number written down. Oh, yes, that's what. It's less than or equal to 5. Now this doesn't want to work. Why should it be 5 and not 4?
It says no.
So more than 5 would be here. So the first one that's not, the last one that's not included is 5. And that's why I always draw that thing off to the side to make sure I don't just do the wrong one on accident. And then, so for that one, you get you get 0.01. I don't have it written down weird. Or do you get, once you subtract it, you get 0.01?
You get 0.01.
And then you do 1 minus that?
No.
Oh, that's your answer after you've done 1 minus. Yeah, okay. I just didn't write down both parts. Yeah.
So is what you like your trials, is that always the same as what you put for your units?
I was thinking about that the other day. Yes. Because I asked that at the end of yesterday, maybe. Yes. And that's the easy way to do it. And I thought, I didn't think about it until the second time I said it, which wasn't on the video anymore. But I should have made a point to say that. She said, whatever you define as your trials, should that be what you use as your units? And yes, that's a good way to, that's an easy way to think of it. Yes, that is correct. How do y'all feel about what we're doing, like going through these problems? Like, am I okay going a little bit quicker, or do y'all need me to slow down and do these? Because I want to give y'all time to work, but I want to make sure we go over these. All right, so a baseball player's batting average is 300. P parentheses means probability. We want exactly 2 hits at 4 at-bats. So this is binomial or geometric. P is 0.3. N is what? And we're finding P parentheses. And this gives us 0.2646. Two-thirds of secretaries in a large stenographic pool are licensed motor vehicle operators. Of the 4 secretaries drawn at random to go on a trip, what is the probability that at least 2 are licensed drivers? Probability, not mean. Do I know how many I'm drawing? Yes, I'm getting an exact number of successes out of those. So it's what? So binomial, my P would be what? My N is, and I'm finding P parentheses X is, so 0, 1, 2, 3, ... Well, I guess I could just write 4. I'm circling, I want which numbers? So I don't want through here. So 1 minus probability that X is less than or equal to 1. And then you should end up getting 0.8889 as your answer. I would want to see this number written out too, but I don't have that written on my paper. All right, a quiz has 6 multiple choice questions with 3 alternatives. What does the 3 alternatives part mean? ABC. So what's your probability of getting 1 right? 1 out of 3. Sheer guess yields what probability of getting at least 5 right? There are 6 of them. Binomial or geometric? All right, what's my probability? 1/3. That came from this number, right? How many other numbers do I have in this problem? Do I have 2 other numbers in addition to probability if it is geometric? No, you would only have 1 other thing. So that's a really good, easy thing. Like, you'd be surprised how many people get to a test and they try to plug in these numbers and they say, I only have 2, I don't get it. Then it's not that. then it's geometric. So use that to help you. Geometric only has 2 numbers you plug in. Binomial has 3. If you don't have enough, it's probably geometric. So my n here is what? And we want the probability that x is. So I could rewrite this as 1 minus probability of x being. What's the other way I could do this? I could just find it for x equals 5 and x equals 6 and then add them together and either one is fine. And you should end up getting your answer as 0.0178 is your final answer here. Number 5, a risky operation used for patients with no other hope of survival has a survival rate of 80%. What is the probability of exactly 80% of the next 5 patients survive? This one's a little bit tricky because it uses this, and that's talking about 2 completely different things. So what is our probability of success? How many am I doing? So that might be why it might be in. Am I doing it until I get the first one or a certain number of? So this is n. How do I find what x is? 80% of n, which is. So some of y'all might have been tripped up on that one. So probability that x equals 4. This is binomial. And that ends up giving you 0.4096. Now, realize that this is a lot less work than you usually have to show for most things, which means if any of this stuff is missing, this makes no sense. So you have to write these things with those problems because we're not writing out the entire equation. Paul's about to take a 5-question true-false test. What does true-false mean to me right now? 50-50. 5-question, that's my n. She is not prepared for the quiz and decides to answer questions without reading them. Find the probability that she gets. So this is n equals 5. This is binomial. So do you understand this scenario in general with like being able to calculate the probability that if you guessed what your chances are of getting a certain number? When I used to teach lower level classes, it was kind of surprising that I could like literally sit there off to the side and be like, if they wouldn't have looked at the questions, they would have had a better chance of getting higher than they did if they had looked at the questions, which is this process of figuring that out. So the first one is probability of x equals what? Which is 0.0313. So a 5-question true-false test doesn't sound that bad, but the likelihood of guessing getting them all right is about 3%. That's not that great. All answers wrong. Well, if I don't ever do this problem, what is that answer? It's 50-50. So you either get all of this or all of the other. What's your answer going to be? But that only works because it's 50-50. And then the last one is x equals 3. And you get 0.3125. And then number 7, a shipment of 100 tires from the tire corporation is known to contain 20 defective tires. Tires are drawn one at a time and checked and replaced. Now, theoretically, would they really check it to see if it's defective and then put it back and then try to check it again? Why is it telling us that? So that it's independent. What is the probability that at most 2 defective tires? So at most 2. And now this is a test where I expect you to write all over it. Shipment of 100 contains 20. Tires are drawn. I could write about this part about being independent. So what kind of problem is A? Why did it give me the 100 and the 20? So probability is 0.2 for all of these. For part A, my N is what? And I want P parentheses X is, and so you do this one as CDF and you end up getting 0.9421. What is the probability that the fourth selection will be well, this should be a giant keyword that is what? The other giant key is that, yeah, it gave me 0.20 up here, but the only other number it gives me is this. So P parentheses Y, what? And this gives us 0.1024. At least 2 of the next 5 binomial or geometric. So P parentheses, so N is 5 here. P parentheses X is what? And I would rewrite that as less than or equal to what? And you end up getting as your final answer 0.2627. What is probably that it takes more than 5 tries to find a defective? Well, that implies what word without saying it? And so that's our first, that's geometric. And takes more than 5, so P parentheses Y is, and I would rewrite that as that it's what? And you end up getting 0.3277 as your answer. Questions on that homework? I don't usually intend to do that homework and the homework before, so I'm hoping, like with break and the cumulative and everything, I think it was worth doing both. So I'm hoping at this point people feel good about these.